Let me put in a graph and some numbers. First, I'm going to plot quantity right there and a variable cost. And the variable cost curve looks something like that. I have fixed cost, and it's a flat line. There it is. And total fixed cost, which is the brown curve right there. It turns out the variable cost plus fixed cost is equal to total cost. If I take that distance there, which is 90, and I move that straight up, that distance there between those two curves, or those two lines, is also 90. In fact, it's 90 all the way through to the end. If I can hold that constant and steady, there it is. It's 90 there as well, from the beginning to the end. Let me move over the total cost column a little bit. And I'm going to discuss that now. It's average cost right now, but let me just slide over right there. Now on the bottom graph, I'm going to plot unit cost instead of total cost. I'm going to plot average total cost. If I take total cost divided by quantity, that's average total cost. For example, if I take 120, which is total cost, divided by a quantity of 1, this should equal to an average total cost of 120, which is green. And I plot 1 and go across right there, and 120 is about right there. And let me put a little dot, a green dot. Let me do another example. If I take 140 divided by 2 in this case, is equal to 70. And let me plot that as well. So I take quantity of 2 and a unit cost of 70, and I put a little dot there. I'm going to put in the rest of the values so you can see them, and you can do those calculations if you want to. Now I'm going to do the calculations for marginal cost. Again, let me move that over so it's right next to what I'm using. Marginal cost is a little different. So if I take an output of 1 and I increase it to 2, what happens is I have a change in quantity and I have a change in total cost. And a change in total cost divided by a change in quantity is marginal cost. So I'm going to do the calculation for you here. So I'll take 140 minus 120 and divide that by 2 minus 1. If I take total cost, which is 140 minus 120, which is the change in total cost, divided by the change in quantity, which is 2 minus 1, is marginal cost, I am taking the change in total cost divided by the change in quantity. This is equal to 20 divided by 1, which is equal to 20, and this is my marginal cost. I'll just put in the curve there. So if I have a quantity of, I'm going from 1 to 2, so my marginal cost there is 20 at that point right there. I'm going to do another example for you. I'm going to go from 4 to 5, and it gives me the marginal cost from going to 4 to 5, which is 20 again, coincidentally. I'm going to make that calculation. I'm going to take the change in total cost divided by the change in quantity. So I'm going to take 190 minus 170 divided by 5 minus 4. Change in total cost divided by change in quantity. This is equal to 20 divided by 1. Or 20, should be 20. So I go to 5, and I go across, and that is 20, marginal cost of 20. Unit cost goes right there, marginal cost of 20. I'm going to put the variable cost column back in, show you something a little crazy. Economists gone wild. No, not really, but anyway. If you look at the change in total cost and the change in variable cost, it's always the same. In the earlier video, I showed you where the slopes of the total cost and variable cost curves are the same. this actually proves it numerically. So it turns out that the change in total cost is equal to the change in variable cost. So the change in total cost divided by the change in quantity is equal to the change in variable cost divided by the change in quantity. And this equals marginal cost. I'm going to add a bunch more columns in here. Quantity, variable cost, fixed cost, total cost, marginal cost, average variable cost. Average variable cost is equal to variable cost divided by quantity. Average fixed cost is equal to, as you probably guessed, fixed cost divided by quantity. I'm going to bring in the average total cost column back again. And average total cost is equal to total cost divided by quantity. So now I'm going to talk about these relationships between these columns. So average variable cost plus average fixed cost is equal to average total cost. And you can see that if you go across the columns, 20 plus 18 is equal to 38. It gets a little messy to graph all these columns, but let me just show you what that looks like. I'm going to draw in the average curve, average total cost curve. The average variable cost curve looks something like that. Marginal cost curve looks something like this blue line. And average fixed cost looks like that. So you can kind of see what those look like. If you haven't watched the first video in this series, I would encourage you to do so. And this would make more sense to you as well. What's up next is the calculus proof. And I know all of you have been waiting for this, but it's a calculus proof of what we've been discussing.